What's up, math fans? Sorry, excuse me 1 second. I was cleaning the board earlier and there's still some residue on the board. Residue. There's still some residue on the board. What residue is leftover stuff. So when you're talking about a residual plot is a plot that shows the leftovers. All right? What that means is first you have to analyze a scatter plot, and then you can talk about what's left over, and you make a residual plot based on the original scatter plot. A lot of people see a residual plot and think it is the scatter plot. It's not. A residual plot is different. It's based on an original scatter plot. So you already seen a couple of my videos that talk about scatter plots, making a line best fit, something called linear regression, and also a correlation coefficient. All of that is related. So what is a scatter plot? It comes from data. It comes from comparing something on the x-axis to something on the y-axis. Check my other videos for actual real-world examples. So I made a scatter plot here based on this data. Here's a table. I already plotted it for you. If you really want to work along with me, oh no, don't look. Just look at the table and plot those 7 points. I think it's 6, right? But it's not because 0 counts as a point. 7 points. Plot them. You should get this. All right? Once you get this, you want to analyze it. You want to ask yourself, well, what am I looking at? Does the data look like any kind of correlation here? It looks like a positive correlation. The points are going up. Then you have to decide, is it a strong positive or a weak positive? The points are pretty close together. I would say it's a pretty strong correlation. My correlation coefficient might be like 0.8. Maybe not quite 0.9. That's a little too strong. Maybe 0.8. I don't know. I can actually figure it out based on my last video, correlation coefficient. You just type in this data and then press stat, calc, linear regression, and you will get the correlation coefficient. I didn't do that. I didn't go that far. I'm going to now try to draw a line best fit, which the calculator would do for you, but let's do it by hand. So what's a line best fit? It's a line that fits the best, that includes as much data as possible, which means I want this about the same number of points above and the same number of points below. So I'm going to do the best I can, and you do the same. I even got my straight edge for this occasion. So I'm going to do my best to go straight down the middle. And that green line is my line best fit. And I had started with 0, 0 and I ended with 6, 6. So I got 1, 2, 3 above and 2 below. That's pretty close. Actually, if you look at the calculator, it might be tweaked slightly above how I did it, but that's pretty close, all right? Might have been better if I included another point here that was below it, but you get the idea. You want about the same above and about the same below, and maybe even hit some. So that's it. That's good. Nice job. So it is definitely a positive correlation. Now, let's look here at the residual. What's a residual plot? A residual plot is you literally take your line best fit and you turn the whole thing and make it a horizontal line. And then you say, look at your points. How are they left over? Remember, I was wiping off the board. What's left over? This point is actually on the line best fit, so it's still on the line best fit. At 1, there was a point above the line, so here's a point above. At 2, there's a point below, here's a point below. At 3, there was a point above, below, above, on. All right, that's what residual is. How are these points left over from the line? Kind of like you wanted to play with your friends and you got left out, wah. So some are above, some are below, some are actually on the line. So it's almost like I'm erasing the x and y axis, and I'm just taking this part, cut, rotate, paste. 3 above, 3 above, 2 below, 2 below. 1, 2 on, 1, 2 on. That's it. That's what a residual plot is. It shows where the points are in relation to the line best fit. Well, that's simple enough. So for this class, I'm explaining this to algebra students, algebra 1. So you don't really need to do all the specific calculations. That's what the calculator is for. what this class is just you to recognize certain patterns. So you might get this graph and not that graph, and they'll say, look at this residual plot. Where did it come from? And you have to realize some are above, some are below. That came from a linear regression. Linear, all right? Of course it's linear, you're always talking about linear. No, there's other kinds. Look at number 2. Look at this thing. Here's this random scatter plot. I didn't even tell you the numbers, just random scatter plot. So you look at it, and let's say you make a mistake, and you say, I think that's linear. Let me draw my line best fit. And you do something like, there's my line best fit, because I thought it was linear, right? If you think it's linear, now we're going to look at 2 possible residual plots and see which one matches. If you think it's linear, then there should be an equal number of points above and below. This is the residual plot of a linear regression, of a linear pattern. But check this out. If this is my line best fit, in the beginning there's a bunch of points above the line. Then there's a whole bunch of points below the line. And then at the end there's some more points above. I only had 2 there. Sorry, I have 2 here. I didn't match it exactly. I just want you to get the picture. So if you're looking at this, this comes from this, okay? But this is not linear. This was a lie. This is not linear at all. If you had a good prior background, you would have stopped me a long time ago and said, no, that's not a linear regression at all. This is actually exponential decay. This is a curve, okay? So I made a mistake, but what is my point? My point is, if you see a residual plot and it's a nice little pattern like that, the pattern meant it came from a curve, all right? So if they show you these 2 and they say which one represents a linear regression, this one represents a linear regression. This one represents a curved regression, all right? Usually they won't ask that one. They will ask this one, okay? So you see a pattern, you think the answer is, oh, a pattern, it gotta be this one. No, it's actually the one that's all messy. This came from linear. All right? Questions, comments? Feel free to leave it in the comment section, and I'll get back to you. Thanks for watching. See ya.